After studying this module, you shall be able to understand the t-test and its three types, learn about the concept of hypothesis testing, about the difference between two independent means between subject design mean, learn to calculate the random sampling distribution of the differences between two sample means, understand the concept of hypothesis testing about the difference between two means which are dependent, that is the within or matched or pair subjects design as we call, and learn to calculate the test of no difference between the dependent means. The student's t distribution or the t-test is the simplest test used to make inferences about population means. Hypothesis testing using t-test involves making a decision concerning a statement about the population parameter such as mean or differences of mean using the sample mean to decide whether this statement about the value of mean is valid or not. Types of t-test. There are three variants of t-test used in hypothesis testing. First is the single sample t-test. This is the simplest form of hypothesis testing about the means in which the comparison of an estimated mean is done against a constant value. The aim is to determine whether the average score on a variable in the population is different from a specific known constant. The single mean t-test is calculated using the following formula: t obtained is equal to x bar minus mu upon Sx bar, where Sx bar can be calculated as Sx upon square root of n. X bar is of course the sample mean, mu is the population mean, Sx is the standard deviation of the sample, Sx bar is the standard error of sample mean, and n is the sample size. The next application of t-test is independent samples t-test. It is used when we have two independent samples like the treatment group and the control group drawn from two independent populations with two different means. In this, a single variable is studied under two different conditions and hypothesis testing is done with the sampling distribution of the difference between two independent means, x bar 1 and x bar 2. The formula of this t is represented as t x bar 1 minus x bar 2 is equal to x bar 1 minus x bar 2 upon the standard error of differences of mean. Here t represents the test statistic, x bar 1 minus x bar 2 is the difference between the sample means, and SE diff is the standard error of differences between the means. The formula for the standard error of the differences in mean is equal to square root of standard deviation squared of the first sample upon the sample size of the first sample plus standard deviation 2 squared upon the sample size or the n2. The dependent samples t-test is the third application, and it is used when we have two dependent samples which are matched or paired in a certain way. In this, a single variable is studied under two different conditions, but instead of drawing two samples from two different populations, a single sample is drawn and the same people are used in both the treatment conditions. In other words, we have data on same people in both the conditions. For example, the same group of people is tested on the mechanical ability test twice. The formula for calculating t is represented as t x bar d is equal to d bar upon standard error of differences of mean. Here t is the difference in means over a standard error. The standard error is calculated by finding the difference between each pair of observations. The standard deviation of these differences is SDD, and SDD is divided by the square root of the number of pairs to get a standard error of difference. This module discusses in detail about the independent and dependent samples t-test. Hypothesis testing about the difference between two independent means, the independent samples t-test or the between subjects t-test. Consider the following example. A social psychologist was interested in comparing the level of aggression of children who play violent computer games with those children who don't. In this, children in group 1 who play violent computer games represent experimental group, and children in group 2 who do not play violent computer games represent the control group. The aim of the social psychologist was to test whether the mean for games is equal to the mean for no games. Mu for games minus mu for no games is equal to 0. That is, we expect the difference between means for the two different treatment conditions to be equal to 0. The above research question is an example of hypothesis testing about the difference between two independent means. In this, we have two different samples and we wish to know if they were drawn from populations with two different means. This is equivalent to saying whether a treatment has an effect given a treatment group and a control group. The independent samples t-test is probably the single most widely used test in statistics. It is used to compare difference between separate groups, and the research design for comparing two independent samples is depicted in the table 1 below. We find that the group, the sample size, the pre-test treatment condition and the post-test treatment conditions for the control and experimental group are like this. The assumptions for the independent samples t-test are the following, and they must hold true if one wants to conduct the t-test for independent groups. Each sample must be randomly drawn from its respective population. The samples should be drawn by with replacement sampling method. The two random samples must be independently selected. There should be homogeneity of variance. The sample distribution of x bar 1 minus x bar 2 should follow the normal curve. The two independent samples should preferably be of equal in size. Steps for computing independent samples t-test. Stating the null hypothesis. The null hypothesis HO subjected to research inquiry about the population parameter is framed by the researcher, and the null hypothesis states that the mean of sampling distribution of differences between the means is 0, or in other words, mu x1 minus mu x2 is equal to 0. The formulation of alternative hypothesis, which can be directional or non-directional in nature, is taken up as the second step. The alternative hypothesis to the null hypothesis is formulated. Identification of the region of rejection is done by specifying whether the alternative hypothesis is one-tailed or two-tailed in nature. HA is mu x1 minus mu x2 not equal to 0 when you have a two-tailed test of non-directional nature. The other two alternative hypothesis type of directional nature can be mu x1 minus mu x2 greater than 0 and mu x1 minus mu x2 which are less than 0. Setting the decision criteria by specifying the alpha level of significance is the next step in line for hypothesis testing here. The criterion to determine whether the null hypothesis is to be accepted or rejected, termed as alpha level of significance, needs to be determined in advance. Alpha level of 0.05 and 0.01 are generally used in psychology, and in a two-tailed test, alpha level of 0.05 means that it is 0.025 at both tails, as we have already discussed in previous modules too. If it is a one-tailed test, it signifies 0.05 region of area concentrated in either of the two tails only. Collection of data is the next step, and data is collected on both the samples, that is the treatment and the experimental group, derived from their respective population. Evaluating the null hypothesis by determining the standard error of differences between means and calculating the t-test statistic labeled as t x bar 1 minus x bar 2 is done using the appropriate formula that we have already discussed, and the t statistic is calculated. Once you have t obtained, the next logical step is determining the critical value of t statistic, and the critical value of t statistic that gives the appropriate proportion of scores in the region of rejection in the tails of the distribution is calculated by finding the value of degree of freedom. The degree of freedom represents the number of individual subjects' data points that are free to vary. The formula for calculating DF for independent samples t-test is DF is equal to n1 minus 1 plus n2 minus 1, where of course the total number of observations in each group is 12, and n1 is equal to 12, n2 is equal to 12, and degree of freedom is equal to 12 minus 1 plus 12 minus 1 equal to 22. The value of T critical is obtained from the T table and is also called as student's T table. These are available in most of the statistics books. The value is taken by matching the degree of freedom value with the corresponding column depending upon the prior assumption of one tail or two tail test and significance level of alpha. The table 2 gives how a student's T distribution looks. We can find the column 1 representing degrees of freedom and other columns ranging from 0.25 to 0.005 represent how the alpha value is distributed in the curve. Stating the conclusion, after calculating the T score, interpretation of T obtained is done relative to T critical to report whether the results obtained were significant or non-significant. For this, we compare T obtained value to the T critical value, and there can be different outcomes. The first outcome, if T obtained is more than T critical, we reject the null hypothesis, thereby concluding that the significant difference exists between the population mean, and a rejected null hypothesis is considered statistically significant. If T obtained is less than T critical, we retain the null hypothesis. The result is considered to be statistically insignificant in this case. These steps will be explained by taking up an example now. A social psychologist was interested in comparing the level of aggression of children who play violent computer games with children who don't. The level of aggression was measured on a scale with total raw score ranging from 1 to 5, where 1 represents the lowest level of aggression and 5 represents the highest level of aggression. The following data was collected on experimental group and control group with a sample size of 5 each. The control group X1 with a sample size of 5 and the experimental group with a sample size of 5 gave the following data. The steps of the hypothesis testing for t-test are followed, and the first step, null hypothesis mu x1 minus mu x2 is equal to 0. Alternative hypothesis mu x1 minus mu x2 not equal to 0 for a two-tailed non-directional hypothesis. Conventionally, we have been choosing the level of significance to be 0.05, and this is done like that here also. So, we have a pre-selected level of significance alpha equal to 0.05. Calculating sample mean and sample variance by using the formula, and we did that and we arrived at the values. The table looks like this now, where the sample size of 5 with the first group following a mean of 2 and a standard deviation of 0.4. The second group following a sample size of 5 with a mean of 4 and a standard deviation of 0.04. The standard error of the groups was calculated, and standard error of differences using the relevant formula was calculated to be 0.04. The t value was also calculated, where t x bar 1 minus x bar 2, after substituting the values from the calculated values of the table, was found to be minus 5. The degree of freedom is found to be 5 minus 1 plus 5 minus 1, that is 8. The t critical at 0.05 alpha level for a two-tailed test with 8 degrees of freedom is found to be plus minus 2.306. The conclusion is t-score observed from our data, that is minus 5, falls beyond the critical value of t obtained from the table. Thus, we reject the null hypothesis as our obtained value is more than the critical value, and conclude that the children who play violent computer games are more aggressive than the children who do not play such games. Hypothesis testing about the difference between two dependent means, that is the dependent samples t-test for within subjects design. Consider the following example. A researcher tested the knowledge of undergraduate students on a series of questions on statistics. After a year, the researcher decided to re-evaluate the students and check whether their knowledge on statistics has increased or not. His aim was to test whether test scores were different on two occasions. In other words, mu of first time testing is equal to mu or the mean of second time testing, or mu time 1 minus mu time 2 is equal to 0, and we expect no difference between the means of the two testings. The above example is an illustration of hypothesis testing about the difference between the two dependent means, as it uses dependent sample design in which measurements are related to each other. Dependent samples occur when each observation in the first sample has something in common with one or the other observation in the second sample. In a data set, the dependent samples often appear as two variables for each respondent in the data set. Repeated measurement data, matched pair data, paired difference data, and randomized block design, they all fall in the category of test for dependent means. There are two ways by which dependent samples can be generated. First is by repeated measures design, in which two measurements are taken on the same individuals. This is a type of pre-test, post-test design in which each individual is measured twice. First in a pre-test condition, then exposed to the treatment, and then tested after the post-test. The matched subject design in which subjects are split into two groups and are matched on some variables and exposed to the treatment conditions. Assumptions about the dependent samples t-test. The assumptions for dependent samples t-test are: a single sample should be randomly drawn from the population. The samples should be drawn by with replacement sampling method. The assumptions of homogeneity of variance is not necessary for dependent means t-test. The score of one member of the pair is not independent of that of the other member, and the two dependent samples should preferably be of equal size. The steps for computing dependent samples t-test. Stating the null hypothesis. The null hypothesis HO about the population parameter is framed by the researcher. The null hypothesis states: HO, the mean of the sampling distribution of the differences between the means is 0, mu x1 minus mu x2 equal to 0. The next is forming the alternative hypothesis of directional or non-directional nature. The alternative hypothesis to a null hypothesis is formulated here, and this can be done as HA, where mu x1 minus mu x2 is not equal to 0. This is a two-tailed hypothesis of non-directional nature. The directional alternative hypothesis can be mu x1 minus mu x2 greater than 0 or mu x1 minus mu x2 less than 0. The next step is setting the decision criteria by specifying the alpha level of significance. The criteria to determine whether the null hypothesis is to be accepted or rejected, termed as alpha level of significance, needs to be determined in advance. Alpha level of 0.05 and 0.01 are conventionally used in psychology, and in a two-tailed test, alpha level of 0.05 means that it is 0.025 at both tails, and if it is a one-tailed test, it signifies 0.05 at one tail. Collection of data. Data is collected on subjects in both the conditions of the treatment following either repeated measure design or matched pair design. Evaluating the null hypothesis. By determining the standard error of difference between the means and calculating the t-test statistic labeled as Tx bar obtained, the formula for calculating Tx bar obtained and standard error of differences are given as below, and it is the Tx bar for differences or obtained is d bar upon standard error of differences, and standard error of differences is equal to standard deviation of differences of mean sample upon the square root of the number of pairs that are being investigated. The standard error is found by finding the difference between each pair of observations, termed as d, and the standard deviation of these differences is SDD divided by SDD by square root or the number of pairs to get the standard error of differences. T statistic for dependent means is calculated by dividing d bar with the standard error, and d bar represents the differences mean of dependent samples. Determining the critical value of T statistic. The critical value of T statistics that gives the appropriate proportion of scores in the region of rejection in the tails of the distribution is calculated by finding the value of degrees of freedom. The degrees of freedom represent the number of individual subjects' data points that are free to vary. The formula for calculating the DF for dependent samples t-test is df is equal to n pairs minus 1, where n is the number of pairs. Thus, if the total number of pairs is 12, the degree of freedom would be 12 minus 1, that is 11. The value of T critical is obtained from the T table, which is easily available in most of the statistics books. Under the table called the student's T table, the value is taken by matching the df value with the corresponding column depending upon the prior assumption of one-tail or two-tail test and significance level alpha. Stating the conclusion, once the T critical and T obtained values are with us, is the logical next step. After calculating the T score, the interpretation of T obtained is done relative to T critical to report whether the results obtained were significant or non-significant. For this, we compare T obtained value to the T critical value, and there are two possible outcomes. The T obtained is more than T critical, we reject the null hypothesis, thereby concluding that the significant difference exists between the population means. A rejected null hypothesis is considered statistically significant. If T obtained is less than T critical, then we retain the null hypothesis and the result is considered statistically insignificant in this case. Let us follow all these steps by taking up a numerical example. A researcher tested the knowledge of undergraduate students on a series of questions on statistics. After a year, the researcher decided to re-evaluate students to check whether their knowledge on statistics has increased or not. The scores obtained by students on two occasions are tabulated below. We found that the 5 students which were tested on two conditions, that is the baseline score and scores obtained after 1 year, were following. Now let us follow the steps and find out if there was a statistically significant difference between the two observations. We stated the null hypothesis HO mu x1 minus mu x2 is equal to 0. Alternative hypothesis HA mu x1 minus mu x2 not equal to 0. It is a two-tailed non-directional hypothesis which will be tested at a pre-selected level of significance alpha as 0.05. We calculate the difference score D, means and standard deviation using the formula that have been discussed before in this text. We find the value of difference D by x1 minus x2, that is score of a student on first occasional testing and the second occasion of testing gives us the value of D for that respective student. The mean is calculated using the regular formula of mu x minus n, and the standard deviation is calculated by the standard deviation formula. Mean was found to be for the D scores of the 5 students as 7 and the standard deviation of D as 5.70. The standard error of differences of mean was calculated by standard deviation of differences or D upon the square root of the number of pairs and worked out to be 2.55 in this case. The T on application of the relevant formula was found to be 2.75 here. The degree of freedom as number of pairs minus 1 is found to be 4. The T critical at 0.05 alpha level, two-tail test with 4 degrees of freedom is found to be plus minus 2.776. The T score observed from our data 2.75 is less than the critical value of 2.77. Thus, we do not reject the null hypothesis and conclude that students have not improved on statistical knowledge in the year's time, or whatever improvement is seen, that may be because of some kind of an error. Conclusion is the population means are not different and the result is not significant at alpha equal to 0.05. The advantages and disadvantages of within subject design. The within subject design has many advantages and disadvantages. The advantages are that it eliminates extraneous source of variation, reduces the probability of committing the type 2 error, and reduces the difference between the two groups of scores due to random sampling. Whereas some of the disadvantages of using the dependent group samples are there are more chances of order effects, practice effects can lead to error and more erroneous scores on repeated occasions can be found. The assumptions of true random sampling does not hold true as the same subjects are used in both the situations when we are testing them. So, depending upon the weight of advantage or disadvantage, the researchers make a judicious choice whether they want to go for a dependent sample t-test or not. Now, when to use an independent and dependent sample design is, we have a number of criteria and let us see in which criteria an independent or a dependent sample design fits. Repeated measure for the same individual area or class, we will not choose the independent sample design and we would go for a dependent sample design. Studies with sample matched in pairs, go for a dependent sample design, and if you have studies matched at random on separate sample, then independent samples design is a better choice. Using SPSS 20 for students t-test. A psychologist is interested to see whether there is a significant difference at alpha equal to 0.01 in the means of learning skills of students and teachers towards the use of a new technical gadget. A high mean on the learning skill means better use of the gadget. Descriptive statistics were obtained, and after entering the variable in the data sheet, group 1 is students and group 2 is the teachers, and the dependent variable in the scores on the learning skills on the gadget. After entering the data in the data sheet, the following SPS 20 commands may be given to conduct the independent t-test for the data. Go to the top of the window and click on Analyze. Click on Descriptive Statistics and Explore. Click on the learning skills into the dependent list. Click over the students and teachers to the factor list. Go to the top of the window and click on Analyze, followed by Compare Means, followed by Independent Samples t-test. Click over Students and Teachers under the group variable, Independent Variable. Click on the button called Define Groups. Type the number 1 which represents students besides group 1 and type the number 2 which represents the teachers besides group 2. Click Continue. Then click over Learning Skills under Test Variables. Click OK and the output is produced. It is also possible to run the t-test for a number of dependent variables in the data by clicking over several variables under the test variables. The SPS 20 will run a separate independent t-test on each dependent variable. The summary of the text. The aim of hypothesis testing is to detect significant differences. Independent t-test design between subject design compares mean between two independent groups, whereas the dependent t-test design or the paired t-test, matched t-test or within design as we call them, compares means between two related groups. The identifying characteristic of the independent measures or between subjects t design is the existence of two separate or independent samples. As with all hypothesis testing, the general purpose of the independent measure t-test is to determine whether the sample mean difference obtained in a research study indicates a real mean difference between the two populations or treatments, or whether the obtained difference is simply the result of sampling error. The method of comparing parameters of populations using paired dependent sample, that is the within t-test design, requires that we pair the items of data as we sample them from the two populations. The null hypothesis in a dependent measures t-test design is that on the average there is no difference between the two groups of scores. The decision of applying independent and dependent t-test for a particular hypothesis rests upon fixed criteria. The SPS 20 commands to carry out the t-test on the data are also discussed in the text.